Hello students, I hope you have understood relations. Today in this video I am going to discuss about the functions. Today we shall learn functions. The concepts under functions are definitions, then we are going to study types of functions, composition of two functions, inverse functions, they are also called as invertible functions, and then we are going to solve the exercise 1.2 and 1.3 based upon this. Now we shall move on to the definitions. First of all, I define what the function is. Let A and B be any two non-empty sets. A mapping f from A to B is said to be a function if every element of the set A has its unique image in the set B. Here these two words are very important. Every element of the set A has unique image in the set B. This will be more clear from this mapping. Here you see, f is a function defined from the set x to set y. What are the elements of the set x? 1, 2, 3 and then 4. In the set y, we have a, b, c, d, e. 5 elements are there. Every element of the set x they have asked. So 1, 2, 3, 4, every element. They are associated with unique images. Why I use the word unique? Because it should not happen like this. There is 1, this also has an image D, or 2, it has an image E. This should not happen. If this becomes clearly, we say that it is not a function. Then how do you define function? A mapping f from x to y is said to be a function if every element of the set x have their unique images in the set y. Here we say f of 1 is A, f of 2 is f of 2 is C, f of 3 is D, and then f of 4 is B. Now, we can differentiate the definitions of relations and functions. In relation, what you can say is, suppose 1 is related to A, it may so happen that 1 may be related to B, or 2 is related to one more element like this. But in functions, every element should have unique images. This is what the difference between relations and functions. Okay, now we shall define what is domain and what is range. Okay, the set x is called as the domain set, and the set y is called as the codomain set, whereas the set of all images is called as the range. And also you will notice that range is always the subset of codomain. Okay, so domain is nothing but the set A is called as the domain, the set B is called as the codomain, and the set of all image elements is called as the range. Okay, and also we can say that this is very important. Range is always the subset of codomain set. Okay. Now, let me define the types of functions. First of all, I define the injective map. Injective map is also called as 1-1 mapping. A function f from x to y is defined to be 1-1 function or an injective function if the distinct elements of the set x have distinct images in the set y. Mathematically, how I can write is, if two images are equal, f of A is equal to f of B, then those two elements are equal only. A is equal to B. Distinct elements have distinct images. In case if I say two images are equal, then those two elements are not different. They are one and the same. Okay? It will be clear from this here. You see, A is containing elements A, B, C, D. The set B contains P, Q, R, S. Here, f of A is P, f of B is Q, f of C is R, f of D is S. Every element of the set A have their unique image, and all those images are distinct. Now you can differentiate. Here, see. In this case, f of A is Q, f of B is also Q. This is an example for not 1-1. Okay, but in the previous video you have seen it is a 1-1 function. Okay. So, the function f defined from the set A to B is said to be 1-1 if the distinct elements have distinct images. Now, I define what is an onto function. Onto function is also called as a surjective function. If a function defined from x to y such that every element of the set y, that is y is called as the codomain here, every element of the codomain has its pre-image in the domain set. At that time, we call it as an onto function. Okay. Whenever the function is onto, at all those times, range of f becomes equal to the codomain. Here you can see. I have defined set A and set B. F of A is Q, okay, F of B is P, F of C is S. Every element of the codomain P, Q, S are the image of one or the other elements of the set A. Hence, this is an example for onto function. Have you got it? Okay. Here codomain is PQS, the range is also PQS. So whenever the given function is an onto function at all the types, codomain becomes equal to its range. Okay. With these two definitions, let me define what is a bijective map. A function f from x to y is said to be a bijective function if f is both 1, 1 as well as onto. That is, distinct elements should have distinct images. In addition to that, every element of the codomain have their pre-image in the domain set. Here you see, x is the set containing 1, 2, 3, 4 and y is the codomain, it is containing elements A, B, C, D. Here what I have, f of A is, f of 1 is A, f of 2 is B, f of 3 is C and f of 4 is D. There are 4 elements, all of them have the images, distinct elements have distinct images, and then every element in the codomain has its pre-image in the domain set. No element, suppose I have here E and kept it as a function. Is it a function? Yes, of course it is a function. Every element have their images. Every element of the set X have their images. Now, is it 1, 1 function? Yes, of course it is 1, 1 because distinct elements have distinct images. Now, may I check for onto? Okay. Now, I have considered A, B, C, D and E are the elements of the set Y. Our Y is the codomain here. But range is what? Only A, B, C, D. This means our range is not equal to codomain. At that time, we say this as it is a 1, 1 function but not onto. Okay. Now, in this example, what happened? Here, it is not 1, 1 but it is onto because f of A, I'll write here, f of A is Q and then f of D is also Q I got. This means image is same for two different elements. It is a function but it is not 1, 1 function. But it is an onto function because every element of the codomain has its pre-image in the domain set. This means codomain is equal to range. Range is PQS, domain is also PQS. This is an example. Okay. In the next video, we shall solve some exercise problems of 1.2. Okay, thank you.